Hello, students. We reaches chapter 14. The topic of this chapter is electrodes and potentiometry, and we learn what kind of electrodes are there and how to use those electrodes for our analytical purpose. Okay, but so let's look at the front page of this chapter. Yeah, this example concerns with the chemical analysis of chemical composition of salts leached from Martian soil. This is Martian, the planet Mars, the surface. Okay, uh, well, people sent several, you know, the spaceship to explore the Mars. Okay, and people now carry this instrument. Okay, and then they um, dig the Martian surface, and then uh, chem- perform the chemical analysis there, and then sent the information to NASA. Okay, and it's very amazing. Okay, this is a chemistry lab on Mars. Okay, so everything was controlled, automatically controlled, by this instrument. According to the program, a measurement of dissolved salts were made by 23 electrochemical sensors. Okay, so it performed. This is the robotic arm of a Phoenix Martian lander scoops. Okay, this one. This is called the Phoenix Martian Mars lander. And then, according to the program, it now scoops the soil. Okay, and then soil uh, was analyzed for with the for these ions. Okay, well, uh, this is the thing that analysis lab. Okay, and you see with this one in the soil, Martian soil was sampled and analyzed. Okay, by this one. This is this upper part is the container with leaching solution. Leach. Uh, Leach means the remove something, yeah, from some object. Okay, so leach it from soil. That means now the salts were removed from the Martian soil. Okay? And this is actuator arm to deliver the canister of a dry reagent. And this is stainless steel sieve to reject a large chunk of soil. Right? This kind of filter, and this is a beaker compartment. But the essential part of this finished Mars lander is the ion 23 sensors, electrochemical sensors. Okay? So people um, wanted to analyze this calcium, magnesium, potassium, nitrate, ammonium sulfate, chloride, bromide, iodide, and pH. Yeah? They want to measure the concentration of these ions and also including a proton. Okay, and so not only these ions but also other electrode measured conductivity, reduction potential, redox couples, and reducible metals containing the copper, cadmium, lead, ferrous, ferric, and mercury. Those ions. Okay, all this analysis had been done automatically. Okay, and then in this analysis, mm, yeah, this is a wet chemical analysis. That means you need the liquid. Okay, but analysis must be as simple as possible. Otherwise, all the complicated procedure may not be applied in this case. Okay, so the simple the the simpler the the better. So in this case, electrochemical sensors were used. Yeah? the sensors based on potentiometry. Okay, and so they carried those sensors and used for analysis. Okay, here the biggest discovery was a completely unexpected. People found high concentration of perchlorate ion, okay, sensed by the nitrate electrode. Okay. I don't know how the perchlorate ion was measured, sensed by a nitrate electrode. Yeah, this is a nitrate. Yeah, there is a nitrate sensor where, but people also found the perchlorate ion exists at high concentration. Okay, and contrary to the expectation, there was no sulfate was found. Yeah, no sulfate. Yeah, this one. This is also very common. Uh, an, I'm sorry. This is anion. Yeah, anion. This is very common anion, but the people couldn't find the sulfate ion. Okay. Anyway, the point here is that electrochemical sensors are that important. So the operation principle is quite simple, and manipulation is also very simple, okay, but very useful. So these electrochemical sensors are widely used for the clinical purpose, for the environmental monitoring purpose, yeah, and so on. Okay, now we will learn that principles here. Before we go further, let's consider the reference and indicator electrodes. Okay, yeah, you'll know the several different reference electrodes and also indicator electrodes. But let me approach it this way. Okay, the reference electrode and indicator electrodes have their own characteristics. Okay, reference electrode, as name indicates, okay, it gives a potential reference. Okay? So reference electrode in Korean, 기준전극. Okay, it is called 기준전극. So it gives potential reference. So reference electrode potential doesn't change, although no matter how big the current flows. Okay. So reference electrode potential doesn't depend on anything. Only it depends on the electrode composition. Okay? So this one, reference electrode, is called ideally non-polarizable electrode, which means that no potential change with current. Okay, here let's look at this figure. X-axis is current, the potential, yeah, and y-axis is current. Yeah? Usually in this the plane we describe electrochemical behavior, yeah, of a certain species. Okay, and reference electrode potential is all the time is doesn't change. Here you see reference electrode potential is here, right? No matter what the currents are. Okay, current in this at this current potential here, at this current potential here. Okay, yeah, this is characteristic of a reference electrode. So we call it ideally non-polarizable. Okay? Polarizer means that the electrode potential changes a lot, with a small change in current. But here reference electrode, with change in current, no potential change. This is ideal case, but actually real reference electrodes doesn't behave like that. Real reference electrode at high current, right? Potential changes begin to change here and there. Okay, but at the small current, reference electrode potential is almost constant. And later on, you'll see, okay, in this chapter that, or not in this chapter, maybe subsequent chapters, you'll see that with a 3 electrode system, the reference electrode potential maintains at a real constant value. Okay, but with 2 electrode system, reference electrode potential may change when large current flows. Okay, I'll explain later too, right? But in the meantime, indicator electrode behavior is really opposite. Okay, potential changes with current. Look at that. This red curve. Yeah? You know, indicator electric potential is not constant. It varies a lot. Yeah, with small change in current, you see, indicator electrode potential changes really a lot. Okay, yeah, but this characteristic is quite useful to study the electrochemical reaction on it. Okay, all right. Since electrode potential is not fixed, so you can drive any electrochemical reaction on this indicator electrode. Okay, so electrochemical reactions can be studied on this electrode. So in this case, we call this characteristics is ideally, I'm sorry, it's a polarizable electrode. I'm sorry, really sorry. This is none. This should be removed. Okay? I simply just copied this one. Okay, ideally polarizable electrode. So potential changes with current. Okay, I will correct this part. I'm sorry. Yeah. Okay, yeah, let's stop here.